Hello, geometry folks, and welcome to Area of Regular Polygons. You need a pencil, a calculator, and then make sure that you write all three of these slides into your notes. So there's a slide that shows you the parts, and then there's two slides that are examples. Make sure they're all written in your notebook. Okay, let's get started. So let's talk about the parts of a regular polygon. The first thing you want to know about a regular polygon is that all the sides are equal in length. That's what makes it regular, okay? So the word regular means every side is the same, okay? So here's a side. This happens to be a five-sided figure, okay? You can do this for any regular polygon. So we could actually have a six-sided figure or a seven-sided figure or an eight-sided figure. Okay, but we're going to just focus on this five-sided figure for right now. The radius is the distance from the center to a vertex. Now, the radius is always the distance from the center to the vertex, no matter what polygon you have, okay? So in this case, the center to the vertex goes there. So this is considered the radius, okay? The apothem or apothem, and you can say it either way, is the distance from the center to the midpoint of your side. Okay, so the apothem or apothem is the distance from the center, so right here, down to the midpoint of your side, which is going to make you have a 90-degree angle there. And this is called the apothem or apothem. Now these parts are going to be very critical in and essential for us to find the area of a regular polygon. So we need to make sure that you know these parts. Now notice that I made a triangle. Okay, that is also really important when we're talking about the area of a polygon. All right, so here are the first example. Make sure that you have both of these examples written down. So we are going to find the area of a regular pentagon, okay? But with this pentagon, we have sides of 4 inches. So it's really important that we know that all the sides are 4 inches, okay? Now, what do we know about a regular pentagon? Well, we know that we could, from one vertex to another, cut it into 3 triangles. And that would help us do what? Find the total degrees. So what we want to do is, the first thing we want to do is find the total degrees of all the angles inside of a polygon. Okay, so remember that was, I could make 3 triangles. It was 5 minus 2 times 180, and that would give us 540 total degrees inside the polygon. Now, how do I find this angle and this angle and this angle? Well, if all the sides are congruent, doesn't that mean that all the angles are congruent as well? So this guy has 5 angles, so we can take 540 divided by 5, and we get 108 degrees. So this is 108, this is 108, this is 108, this one's 108, and this one is also 108. Not going to fill that in right now because I'm going to make a triangle there, and we're going to talk about that here in a second. So now that I have every angle, what I can do is now I can make that triangle that we talked about with the radius and the apothem. So we have this triangle, okay, and we have a 90-degree here. And now remember, the whole thing was 108. But I didn't want to write 108 there because now what I've done is I've cut that angle in half. So actually I have 54 here and 54 here. Okay, that's why I didn't write the 108 there. There's still 108 there, but now because I'm talking about one part of that triangle, I need it to be just the one side of the angle, which is half of 108. So now let's take our triangle. Okay, and I'm going to get rid of that degrees up there because my triangle is kind of in the way over there. So I'm going to erase all this here since we found the total degrees. Okay. And now I'm going to use that triangle to help me find the area of this regular pentagon. So what I know about that triangle is that this side is 2 inches. Why is that side 2 inches? Well, when I dropped my apothem and made that 90-degree angle, I cut the side in half. So that's 2 inches now. Okay. Now I know that this is 54 degrees, and I know that's a 90-degree angle, which is really important because we can do a lot with 90-degree angles and 90-degree triangles. So now what I want to do is, if I'm looking at this pentagon, I can see that I have one small triangle here. Well, I can make that triangle over here too. So these two triangles are essentially the same. How many more of these triangles can I make? Well, I can make one more here and one more here, and I can make one more here and one more here. It looks like for every side, I can make 2 of these kind of triangles. So if every side, and there's 5 sides, can make 2 of these triangles, I can actually make 10 of these little triangles. So if I find the area of this just one triangle, I can multiply it by 10 and get the total area of this pentagon. Okay, so let's focus on trying to find the area of this little one. So what I can do is I can use trig or SOHCAHTOA to help me find other parts of our triangle. So first, let's talk about what do we need for an area of a triangle. Well, if you have your formula sheet out, area of a triangle is base times height divided by 2. So we need a base and a height. Well, I have a base of 2, but I certainly do not have a height. Well, my height is my apothem. So I need to find this apothem or this height value. So if I'm standing here, okay, then I am looking for my opposite and I have the adjacent, which means I can use tangent of 54 is equal to the height over 2. And that would equal, if I cross multiply tangent of 54 times 2, I will get x, or my height, is equal to 2.75 inches squared. Oh, 2.75 inches, excuse me, not squared. So that's my height. My height is not squared. I apologize for that. So it's 2.75 inches. So now I can find the area. The area is base times height divided by 2. So my area is also 2.75 inches squared. That's where I was getting that before, sorry. Because 2 times 2.75 divided by 2, it stays 2.75. Okay, so the area of this one triangle is 2.75 inches. But remember, how many times could I draw this little triangle within my pentagon? I could do that 10 times. So I'm going to take that times 10, and my total area for this pentagon, for this specific pentagon, because remember, all sides are 4 inches, would be 27.5 inches squared. Okay, so that is when we talk about a regular pentagon, that is how we would find the area. Okay, let's do one more. And I need you to write this in your notes as well. We're going to find the area of our hexagon. Okay, but this time it's telling me I have a radius of 9 inches. So we're going to have to figure out where we're going to put that in a second. First and foremost, let's find out how many degrees are in a hexagon. So if we take 6, because a hexagon has 6 sides, so you notice 6 sides, and they're all the same, okay, times 180, I would get 720 degrees inside this whole thing. Now, I want to know how many degrees are in each one of these angles. So I would take 720 and divide that by 6, and that would give me 120 degrees. So I'd have 120 degrees here, 120 here, 120, 120, 120. Okay, again, I'm not going to fill out this 120 because I am going to put my triangle there. Okay, that's the triangle that I'm going to put there. All right, so drop down, make a 90 from your center to your vertex. That is your radius. So this is your radius, and the radius is how much? 9. So I'm going to use this triangle over here, but I'm showing you how and where I got that triangle. So this is my radius, and we know the radius is 9 inches. So I'm going to label my radius 9. Okay, here's where my 90 degree is. Okay, now if I know this whole side is 120 and I drop the radius from the center to the vertex, it's going to cut that in half. So it's not going to be 120. Each one of them is going to be 60. So I'm going to have a 60-degree angle there. Okay, so now what I want to do is I want to find the area of this triangle. Then I can take the area of that triangle and I can multiply it by how many triangles I would have of that exact triangle in my hexagon. Okay, and remember this is a regular hexagon. Okay, so regular hexagon, meaning all sides are the same. I can make 2 triangles for every side. And there's 1, 2, 3, 4, 5, 6 sides. So 6 sides times 2 of those triangles would mean I'd have 10 little triangles. Or excuse me, 12 little triangles. It was 10 in the last one. It's 12 in this one. So I can take the one area I find here and multiply it by 12. All right, so let's find the area of this triangle. So it's area equals base times height divided by 2. I don't know the base. And I don't know the height. So we're going to have to use either some trig. So if we're standing here, we could, if we want to find our base, we could do cosine of 60 is adjacent over hypotenuse, okay? Not the height, but the hypotenuse. Okay, this one is height. This guy is your hypotenuse because it's across from the 90-degree angle. So we could do that. So that would be 9 if I wanted to do that way. Okay. You could also use your 30, 60, 90 rules because I have a 90, I have a 60, so this must be a 30-degree triangle. So this is a 30, 60, 90 triangle. And that is hypotenuse is equal to 2 times the short leg. And if you know the hypotenuse is 9, then you can say the short leg is 9/2 or 4.5. Okay, so your base here is going to be 4.5 inches. Okay, now I need to find the height. All right, well, how am I going to find the height? Well, this is pretty cool because what I know is that I can either use trig, okay? So in this case, what I would do is I would do the sine of 60 is equal opposite over hypotenuse, which is 9. Okay, you could do that. Or you could use the 30, 60, 90 rules, which, if you know that long leg, the long leg is equal to the short leg times the square root of 3. So the long leg, which is what you're trying to find, is the short leg, which is 4.5 times the square root of 3. So the height would be 4.5 times the square root of 3. And if you didn't know the 30, 60, 90 rules, you could also use the Pythagorean theorem. So 4.5 squared plus the height squared, okay, so that's your y, times 9 squared. So a squared plus b squared equals c squared, and you could solve for your side, your height, using that. It doesn't matter to me how you find those values, just as long as you use one of those ideas to get your answer. So now we have the height, we have the base, and now we can find the area. So let's go over here and find the area of that one little triangle. So it's base times height divided by 2. When I plug that into my calculator, I get 17.54 inches squared. Okay, that's the area of that little triangle. And remember, there's 12 triangles, so we're going to take that times 12, and our total area is going to be 210.4 inches squared. All right, that's all I have for you today. Thanks for taking good notes, and we'll see you tomorrow.